everyone, my name's Luke Parker and this is another Bracebridge Engineering video. And in this video we're going to be talking about the two different types of tooling that we commonly use on parts, progressional tooling and conventional tooling. Now you probably don't want to be staring at me all the time, so I'm going to quickly flick down in a minute to the tools I've got on the desk in front of me. But the purpose of this video really is just to explain the differences with the two different types of tooling and how it may impact the cost of your parts and the cost of the tooling. And how we produce them. Quite often you may see on a quotation you've received made with progressional tooling or made with follow-on tooling or made with conventional tooling, and I'm just going to try and explain a little bit what that's for. So I'm just going to turn the camera around now if I can. Okay, it appears that we can't switch the camera around while we're recording, so I've started another one. Okay, so I've got here two different jobs, but quite a lot of tools for the one job and just one tool for the other job. We'll start off with the more complicated one. Now this is the conventional tool we talk about. By way of conventional, what we mean is it's done in a conventional way, i.e. each stage is done in one progress. Now obviously there is an individual setup time for each of the operations, but the end part for this particular set of tools is this little part here. It's a little insert that goes into a cap. Now one of the part stages of that is this little part here. That comes off of this stage when you clip that inner ring off. But you may be asking, well, why would you go and tool up this way for a part? Now, to be quite honest, we'd never make a part like that this way. The only reason we did with this particular job is because it's only a requirement of about 500 parts a year. So there's no point in making a progression tool to do that. Obviously with a progression tool, which I'll explain in a minute, you'll make, every time the press comes over, you make one, and there's no tool changes. You put one tool in, you can make a lot more a minute, so you can do anywhere from several thousand up to hundreds of thousands an hour if you've got high speed presses. So the capability there is quite great. With conventional tooling, the benefit generally is just down to the tooling cost. Although there's more tools, each of these tools is a lot more simpler to make than a progression tool. With progression tools, you have to think about how the strip is carried along, what happens to each stage, and balancing all the tools out, and you have springs and all sorts of stuff. With this one, you just have the die sets, which is the base plate and the pillars at the back, and then obviously the sleeves and the top, and then you've got the gubbins in between. Repeat that basically for all the different ops doing the various different things, and you get the final part. It's actually quite interesting. I've just had an email today off a customer. He said, I've actually phoned him back, and he said, well, quite often for some reason on this job you're quoting for, the people who have quoted the highest part price are the lowest tool cost, and the people with the highest tool cost have quoted the lowest part price. Well, the reason for that is, obviously, if we're making this part conventionally, it's going to cost quite a lot, because each tool has to be set up by the setter, it has to be run and then taken out, and then the next one. Whereas with a progression tool like this, you feed the material in, raw material, finished part comes out at the end. More expensive tool because it's more intricate, but obviously it's going to be a lot more cost effective to make because it's faster. So that's the conventional tooling, and that's, if you see on your quote, that's what it means. It means the job is done in a series of separate operations. So obviously the setup costs in each of those operations. You can't run these very fast. An operator can probably run somewhere like comfortably 500, maybe 700 if it's a part an hour each, and then they've got to go into a bin, they've got to be rehandled, put back in another tool and handled again and handled again. You will pay less on your tooling, so if you've got a short run, maybe conventional's the way to go. We'll move on to progression. Now, I've sort of cheated a bit. It's not a full progression tool, as it were. This makes this little stainless steel clip here, and I think it's for a miner's helmet, I think this one. Raw material, flat material comes in through here. You can see these punch holes here. Now, they are the 4 holes on this part. You punch to one side there, and then it moves over to that one and punches those. It then goes in and crops, and then drops out here as a raw flat part. Then the flat part is then put onto this part, which isn't the true progression part of it, and then it's stamped with this form on this tool to get that U raised there. Now, forget that part. This part of it's a very simple sort of follow on what we call progression tool. Ideally, if they would have spent a bit more money on this is probably a lowish volume part as well. You could have get the finished part off in one go, and that's the desired requirement for a progression tool. As you can see, it is a little bit more intricate than the conventional tooling. You've got to spend a little bit more money and a little bit more time and thought in designing the tool, but they're really great for high volumes. If you're anything sort of over really, you know, 5,000-6,000 parts and above, depending on the part, progression tooling is the way to go. You will spend a little bit more on the tool, but obviously it's modular, so you've got various different stages that can be unbolted and changed and repaired. If one of these punches goes, as long as the operator's checking the part, he'll see that one of the holes is missing or there's a bit gone in the tool. It can be replaced relatively easily. So there, if you see a higher tooling price and a lower part price, or the cheapest part price, they've probably done it with a progression, especially if it's a little bracket or something like this. Like I said, we're quoting a job at the moment, and it's just like that. We're quoting it a progression tool purely because we can try and get the part price down for him. So that was a little short video, really. It wasn't a very long one, but it just hopefully gives you a bit of information and a bit of help when you maybe are looking to make a product. Depending on your volume, it's much like most things. There's always a compromise with tooling. Cheaper tooling, you'll always almost pay more for the part. It's just the way it works, and hopefully I've demonstrated that in the video today. Thank you, everyone, and next week we'll be doing another video, probably again on tooling, but maybe something else. Tune in then. Of course, you can follow us on social media. At BBE Pressings is our Twitter call, and also now on Instagram as well. So yeah, we're branching out. So thanks for watching, everybody, and we'll catch you again next week. Bye.